keeping you connected and protected.
Welcome to DAS Talk, the essential podcast on distributed antenna systems and in-building communication. Hosted by Peter, VP of Gamma, and Philip Nicholas. This Gamma Electronics series focuses on emergency response and safety. Join us as we navigate the challenges of building effective communication systems for North America's first responders. We delve into the advancements in emergency responder radio systems and the transformative impact on new technologies. Tune in for insightful discussions aimed at increasing knowledge and awareness in the DAS field. Whether you're a professional or an enthusiast, DAS Talk is your gateway to understanding the nexus of technology, safety, and communication.
All right, guys, what's up? Welcome to today's DAS Talk. We are in Fort Lauderdale at Motorola, with Rich Jimenez and with Rick Rausch from Gamma. We are really excited to be with you today. We've got a great session in store. We've got beautiful weather in Fort Lauderdale. It is a beautiful day, and what a great day to be alive. I hope everyone is doing their DAS thing and building those builds and keeping that interference down. With that said, I'm going to give some time over to Rich, and he's going to go ahead and introduce himself a little bit more formally and tell us about what he's doing at Motorola, what kind of work he's been up to, and stuff like that.
Thank you. I'm Rich Jimenez. I've been in the DAS space for probably 35 years, something close to that. Mostly working as a subcontractor at Motorola, but 5 years ago, Motorola was looking for somebody to start the BDA integration business here in Florida. We started in Florida in 2020. We grew it to encompass the rest of the Southeast in just a couple of years, and then just last year we went national. We were focused just here in the Southeast, but now we're focused nationally, doing direct BDA implementations ourselves, design, build type applications, as well as doing that same type of work, but with partners as well, with our partners like MCA and Bearcom and the like.
All right, fantastic. We also have Rick. Rick, go ahead and tell us a little bit about yourself.
Yeah, thank you. Appreciate it. Rick Rausch with Gamma Electronics. I have a long history in the DAS industry for 29 years now, from being a wireless carrier, RF engineering manager, to being a DAS integrator for several years, as well as being equipment manufacturer world as well. So I've been supporting a lot with public safety for, probably the last 16 years. Within building wireless and DAS, as well as being an educator in the DAS and AHJ community as well. So I'm really excited to be here with Rich. I've known Rich for several years, and excited to be able to interview Motorola in general as well. Thank you. Awesome.
Thanks, Rick. Appreciate it. So, we're going to dive right into it. In the world of DAS and in building radio, there's a lot of great things going on, right? Because as you know, there's a lot of stakeholders in this industry. There's a lot of players to get involved. It's not so simple. You're kind of diving into code, and code can get sticky. You're navigating through different jurisdictions, and Motorola, most people know them by their radios. Most first responders, a lot of them use their radios. And now they've kind of turned a new leaf, it looks like, and they're diving into this DAS world in a very, very different way. So, Rich, can you tell us a little bit more about what Motorola has been up to specifically, and why you guys went national, and how'd you make that change? You seem to be an intricate player in this whole thing.
Well, we've had quite a bit of growth in the 5 years that we've been integrating BDAs on our own. Well, one of the reasons why we went national is really the same reason why we started here in Florida. We saw a space that, although had a lot of players in it, not all the players were doing it right in terms of implementing BDAs. What we want to do is we want to do BDAs right. We have a lot of great partners out there, and a lot of internal resources that have been in this business for a very long time. And we have the skills and competencies to do them right. And what we want to do is we're partnering. We don't do the installations ourselves. We design systems. We procure materials. We do the full implementation, but we use partners and to do the installation work. And we want to elevate their game by bringing all the best practices that we have developed in the 35 years of BDA business that I've done.
You want to do it right.
We want to do it right. We want to elevate our partners and our installers along with us.
Got it. Okay. Appreciate that sentiment. So, I think about doing installs right, and I think about doing builds right. And what exactly does that mean? Now, you were speaking to me briefly about some of the problems that happens when things aren't just right. You were talking about a T-Mobile and a public safety DAS build. That was kind of astounding to me because the first time I heard about it, and it was unique, and it totally caused interference in a macro network. Why don't you tell us a little bit about that? Because that was a big deal.
Yeah, actually, I've seen two instances where a building has either had a BDA system and then another BDA system was implemented within it, two separate BDA systems for two separate customers. We all know about isolation, that you have to have 20 dB of isolation above system gain to make sure that the BDA doesn't go into an oscillation
in a single system.
Yeah.
Can you guys explain that real quick, please? I don't think all our listeners understand that 20 dB of gain. What exactly does that mean? Maybe because that's a great point. Rick, could you just elaborate on that just a little bit? What exactly is the difference?
So the way I like to explain it is that it's like feedback. So you know how like an audio system with a speaker and microphone, when you get too close to the speaker with the microphone, it screeches. Well, kind of like that with a BDA or a DAS system actually too. If the donor fed signal that's coming out, it feeds back into the serving antennas. That RF delta needs to be 20 dB so that it doesn't screech. Or what happens is the gain of the system goes down, which means the coverage shrinks. When there is an oscillation or isolation problem, that system's RF coverage is greatly impacted.
Right.
So that's what you want to avoid.
And then also what it can cause is it can cause interference carriers to be generated. And in this system that we just looked at last week in Atlanta, two carriers were being developed on frequency in Uplink that were basically totally desensing the receiver of the system. And several channels, I think 7 out of 27 channels had to be shut down because of this interference.
Were they control channels?
3 of them were control channels. They lose one more and the system's done. Right. So
and what region was this again?
Atlanta. This is in Atlanta.
Can you explain for the audience though, what's the major importance of the control channel? Why is it different?
The control channel, it's up all the time and it's supplying all of the head end information to all the radios. It's telling all the radios in the system, all right, you're registered on the system here, and your radio can work. So all the head end background data is flowing all the time through the control channel. Control channel is always on. You need the system won't work without a control channel. And 3 of the 4 control channels on the system were down.
So we were this close,
very close,
bringing down the whole.
Right. Exactly. So getting back to the 2 BDAs, they were in this building, and they were cross-oscillating with each other. So although when this BDA was originally installed, its isolation was proper. It was measured to be proper, and they put the BDA in service. Well, somebody else came along and put in the second BDA, and this one probably was aligned, so its isolation was fine. But what they didn't do is they didn't measure the isolation between the 2 systems, and really nobody knows to do that. I do, because this is now the second time that we've seen this.
This is the second time.
Not just here in Atlanta. It happened just up the road in Orlando.
Right, down south too. I talked with an integrator 2-3 years ago who needed to change out the donor antenna because somebody put up one behind his
Yeah. Now, there are ways around it. I mean, if you're doing BDA work, you and I were talking about this, or no, you and I were talking about this. If there are two buildings next to each other, the ideal way to make sure that we get coverage into both these buildings is to put a BDA system in there that only has one head end. If it had one head end and then connected via fiber with two remotes, one remote in each building, then you can provide the coverage. And although you still have to maintain isolation from the donor antenna to the coverage antennas, you only have to do it with one system.
That's right.
And therefore, that is the best way to.
So I like that idea, right? So if you've got two buildings and one donor antenna and one head end, you still run into some challenges. We kind of touched on that. So some of the challenges are going to be, well, if it's one building, if it's one owner who owns both buildings, no problem, right? We all agree there's no problem because it only makes sense for him to take advantage of the already existing infrastructure if one already has one,
Right.
Or he saves money with having one head and two buildings. But where the big problem comes into play is when you have two building owners, right?
Correct.
So then
Getting them to cooperate towards getting this solution implemented has proven to be pretty difficult.
Sure. Now, maybe you can elaborate on what would be the benefits to both building owners cooperating. Do you guys think that would reduce the costs on the build? I mean, if they split it, right?
Yeah.
Or do you think it would increase the costs?
I think it would reduce the overall ownership cost to each of the owners.
Okay.
Because you would share the cost of the two remotes, share the cost of the single head end, and the fiber between the building. I think it would be a less expensive purchase for them.
So there's financial gain, right?
There is
Financial benefit.
and the benefit of having
Clean systems.
And-
Clean systems.
right, that doesn't and a system that addresses the network integrity issue at the far end. Because if you have two BDAs in buildings next to each other, let's say they don't interfere with each other in ideally, but when you have multiple donor antennas, multiple BDAs all pointed back to one donor site, one receive site, then you have multiple devices all trying to transmit uplink to the base station, and BDAs are inherently, they have noise. There is noise. You can attenuate it out, but some noise is going to hit the far end. And as you add BDA systems that all looking to that one donor site, you're going to noise up the system. You're going to noise up the environment.
There's no way around that. I mean, when you have more building in areas that there's more and more construction, you're kind of battling this thing, right?
Right.
You're battling, well, BDAs are good when they're used properly, right? Interfere with the macro is really, really, really bad. So we got to be able to manage both.
Correct.
Right. And that seems to be, and that's where you're talking about where when you first started this conversation, I really like what you said. You said you need to do it right. And so I want to know what that means. What's doing it wrong and what's doing it right?
For one example, what I just used, if you have a campus environment where you have multiple buildings and that require an enhancement for coverage inside, and you have 7 buildings and you have 7 separate BDAs all looking to the same site. That's really not the right way to do it. What you want to do is you want to have one head end and then run fiber to all the buildings and put fiber remotes at each building. And therefore, only one site is actually communicating. One head end is communicating to the base station, and the rest of the buildings are tied together to that one head end. It's a cost-effective solution, and it protects the network integrity, which is really the most important thing.
Absolutely. Yeah, so it sounds like to me that Motorola is really engaged in this in a very, very good way, and that's fantastic. And that's also very good to hear. It sounds like you've got a lot of great partners involved who are also doing that, and you're doing things because you guys understand the macro network part of it and the radio part of it. You can really bring that RF expertise with some of the DAS installers. Even though you're not installing yourself, you're really bringing that to the table. Sounds like it would be really great to partner with Motorola.
It is. We're doing a lot of BDA work across the country, and we're bringing our partners along with us at every location. One of the other things that doing it right means to me is really what I've been harping on since I got here, and that is doing uplink commissionings on every single BDA. Anybody can pull the downlink off the air with a Yagi antenna, put it into a BDA, and then distribute it through a building. That's fairly common.
With that downlink, you're talking about the control channel from the tower being read inside the building. That's only the first path.
Correct.
The second path is when you key up the radio from the building.
Right. So you're inside the building now, and you key up your radio. The radio generates the RF signal. The DAS and the coverage antennas receive that signal and then send it to the BDA. The BDA amplifies the signal, goes out to the donor antenna, and then that donor antenna is sending that signal to the receiver on the base station side. Anybody can do the downlink with a spectrum analyzer and a Yagi antenna. But the most important part is uplink and how that signal is received at the base station, and that it's not noisy, that it's not that the BDA is not going into oscillation. So what you have to do is you need to plug into the receive multicoupler, measure the signal at the at the receiver, and make sure that it's in kind of a sweet spot. So same between like neg 75 and neg 90. Right in that sweet spot. And that makes sure that you have adequate signal at the base station in uplink, and that you're not overdriving that signal into the base station. Because if you send too much signal in, more is not necessarily better here. You want to send only as much signal as you need to the base station to make the system work.
So you're basically saying that theory some people have of turn it all the way up and blast as much as you can. That's a bad idea.
That is a bad idea.
Yeah.
That is a bad idea. The more that happens, the more you elevate the noise floor in that particular part of the spectrum.
So I know this to be true because I know, for example, there are jurisdictions in the United States where first responders go into, and there are noisy zones. They don't know exactly why, but their radios don't work, and it's because there's too many BDAs. The BDAs are not managed properly.
That could very well be. Yeah.
I know for a fact.
Yep.
And that is very troublesome. And for those jurisdictions where you've got multiple first responders complaining about their radios aren't working in certain areas, this is the reason why.
Yeah.
This is absolutely the reason why, because there's no one kind of QCing what type of integrators are going into that area.
Right.
They're not making sure that the people commissioning them are well trained and understand RF and are overseeing and making sure the noise floors and impacted.
Training and education are absolutely essential in this business.
Agreed 100%.
Training of who? Let's talk about the stakeholders that would need training.
From the fire inspector who's actually doing the inspection of the BDA work, the integrator who's designing the system, the installer who's installing it. Everybody every stakeholder that's involved needs some level of training to fully understand what these systems do.
And how about the radio network manager? This is a really unique role that I wanted to highlight for Motorola, because you guys are actually building the tower network, right, and doing a lot of the management and maintenance, critical to the radio communication for first responders. How do you work with the county and city radio network, or FCC license holder is a big name within the community related to the United States? Obviously. Yep. They buy the license, and being Motorola, you're helping maintain that license doesn't get interference with. So how are you working with those radio network managers?
We have several counties around the country that engage us, not only to optimize our own BDAs, but have the other integrators within their dirt contact and engage Motorola to do uplink commissionings for their BDAs, to do also acceptance tests. We do their acceptance tests because a lot of times the counties don't have the resources to do that themselves, nor the expertise.
That's important.
So they have the integrator that's maybe not a partner of ours, that's implementing a BDA for them to call Motorola, get Motorola on site, make sure that the BDA is installed properly. We do a full inspection of the BDA. We go over the optimization and alignment of the BDA, do uplink commissioning at the base station, typically with one of our macro site techs, or we can dial in. That's how old I am.
I'm with you. I'm fine.
I understand that. Believe it or not, I'm not that young.
So, to look at the
DB level,
the receive multi-coupler remotely to measure the uplink. Then we'll go and we'll do an acceptance test to make sure that the BDA system that's been implemented is meeting the requirements of that.
So let's say you're working with an integrator that's commissioning a BDA or a DAS system that day. Your technician at the tower, if the signal's coming in too strong, what do you tell them to do?
You can do it a couple different ways. You can either put a hard attenuator in line in uplink,
Okay.
or you can turn down the gain within the BDA. Two easy ways of doing it.
Yeah.
One of the first things that we do is we'll measure the noise floor on the output, and BDAs typically have like a 6 dB noise figure. We'll immediately attenuate that out to make sure that as little noise as possible is going towards, and then we'll adjust the gain depending upon what the near and far effect we have at each antenna. Near far effect is there's an antenna that's closest to the BDA, and that would have the shortest loss between the BDA and the antenna. And then there's one that's the furthest one in the system. You want to make sure that anybody that's in the DAS network, that they can use their portable, even if one guy is standing at the close antenna and hitting the BDA really hard, because there's just only a little bit of loss. You want to make sure that the guy at the far end can also communicate. So we do near far effect measurements and alignment, and then we do the far end and make sure that the signal level is getting to the base station at the right level, not too much. You brought up a good point earlier. I mean, a lot of people think more is better. More power is not necessarily better. Not in downlink and not in uplink. If you have too much downlink, then you're getting out. Then you're
Egress. You've got egress.
You have egress out of the building. You want to limit that as much as possible. Usually, what you want to do is your design. And you do this in the design side. You want to limit the effect of the propagation of your coverage to the exterior of the building.
So are you guys able to do your uplink commissioning on any BDA manufacturer?
Sure.
Wow, that's fantastic.
Yeah.
So no matter what brand, you guys are able to go in and kind of do this final acceptance testing and uplink commissioning. That's right. I think that's fantastic. That's right. I think that's a big deal, because I think a lot of people are only, BDA brand specific, and there's half a dozen, maybe closer to a dozen different brands of BDAs out there. Different even jurisdictions. Some will even ban BDAs from being used in their jurisdiction because they don't like them because they're noisy or whatever. Sure. We don't get into that. That's not my job to determine that. But that's perhaps the radio frequency license holder or the AHJ who's kind of involved in that kind of thing. But that's really cool that you can determine that.
Yeah, Motorola is generally manufacturer agnostic. We select the BDA of choice for an application based on the specific needs of that facility or the frequencies that they want to bring in. Everybody knows there's a lot of 800 megahertz BDAs out there because of public safety. Public safety is in the 800 megahertz space, mostly. But there's VHF and UHF as well. Yeah. And sometimes they want all three bands, or four bands. We consider 700 and 800.
Long Beach, California.
Yeah.
Right.
I mean,
New York City also has
VHF, UHF, 800.
900.
Yes. 900. I was listening to it. I think they have 4, and I was like, "Wow, it's never ending." Like this, they're in a whole different world up there. Maybe we could have a whole episode one day about New York City, because on what they're doing, because they've got ARCs and they've got and then they don't share their network, and it's kind of wild over there. So
UHF and 800 megahertz, they're relatively easy to work with, because there's set splits between the uplink and downlink frequencies, or the transmit and receive frequencies. But at VHF, that's really where it becomes a problem, because there's no set split between transmit and receive, and you can have 4 transmit frequencies and one receive frequency right in the middle of them. With one day I think the FCC might do something about that, but
Until then, you gotta work with it.
Good deal. I think we've talked and we hit a lot of great topics here in this discussion today. It was definitely a thrill, being here in the beautiful city of Fort Lauderdale. My grandmother lived down here and in this area, my late grandmother. So it is truly a beautiful state and a wonderful place to be. I'm grateful that Motorola lent us their facility here and was willing to, host us at this lovely location. John Munch has been a big help to us. Appreciate that. And Rich, thank you so much for being on with us. And Rick, thanks for joining us for your first flagship episode. Is really kind of cool too,
Couldn't be better.
Yeah, it's good to hear. Normally Gil Martinez is on with us, but he obviously is back west where he's supposed to be. So, gentlemen, thank you very much, and thanks for being with us, everyone.
thanks for having me.
Thank you. Wow, that was great, man.
Yeah, some good stuff. Good stuff, brother.
Good things.
That was great.
Fast Talk by Gamma, keeping you connected and protected.